Elizabeth. Hey, who's Elizabeth? How am I calling Elizabeth? Juliet.
It's, one of your girlfriends is called Elizabeth.
No, maybe yeah, you are right. Maybe I've been thinking about an Elizabeth. It was possible. Yeah, this evening I was thinking about a certain Elizabeth. That's true.
Say.
Sorry about that. Don't be jealous. We are very fine, right? Uh, so we have problems when we fly very high. There's a decrease in pressure. It gets extremely cold. Things get complicated. Is that okay? So at a point, photogrammetry has to end. If you have to fly very high, you might as well use a satellite and use remote sensing, which is another technology altogether. Excuse me. So yeah, you need to understand the number of flight crew that can go on it. Above 10,000 meters, you will need oxygen. All right. Under pressure, put it inside some kind of container. Is that okay? Cabin pressurized heaters required. Are you okay? So it's like you are really traveling from Accra to London. All right. So why bother? I mean, you have to take all this into consideration so that you are not ignorant. The type of equipment platforms that can be used. We can talk about supercharged single engine biplane. Are you okay? So you can have single, twin engine, so you need to know which one you're going for. One goes higher than the other. Are you all right? This is what before the Zoom ended, the previous meeting ended. I wanted to say that this is what makes you an engineer. Your ability to decide on what to choose, what to do and what not to do. That's all. You don't have to be the one inside the airplane anyway. You don't even have to be. So let's know that what we are doing now is more important than anything else. Okay. Higher altitudes require turbocharged jet. Okay, of course. Proper flying heights maintained by altimeter. Okay, so the altimeter also helps us in determining the flying height. When you even sit on an airplane from you travel anywhere in the world, you see the airplane has an altimeter that tells you where you are. But it may not be that accurate. Always remember that engineers are interested in accuracy. Okay, it's not about just getting something approximate. It won't work. Okay, so yep, you can have barometric instruments or equipments which are affected by pressure, and you need to double check them and make sure they are okay. All right, so this is our photographs, about 6 photographs superimposed, and it shows an area called a neat model. Okay, the neat model. The first time you meet the word neat will be in cartography. Okay, in cartography, we have a certain area, okay, which we call the neat, area or something like that, neat region, something like that, And so you meet it again in photogrammetry when we talk about a particular area where we obtain the stereo model for so many overlapping pictures. So here you can see that we have 1, 2. Let me just get my annotation going. You have photo 1. So the center of photo 1 is around here. Center of photo 2 is around this place. Center of photo 3 is around here. 4, 5, then 6. Okay. So how many fly lines do we have on this? So you need to see some of these things. It's very important. The fly line always goes through the exposure station. So that there's one fly line going here. There's another fly line going there. Then there's another fly line going here. Okay, this one I didn't draw it very well, but it's going through where I think this one I'll have to reject it. Okay, so it's somewhere here in the middle. Okay, and then the next thing we need to do is to establish a stereo model, a stereographic neat model, stereo model. That's another name for it. First, let's understand that from here to here is a side lap. Okay, why is it a side lap? Because it's the overlap between the two strips of photographs. So you go this way and you're coming back. Are you okay? You go in this direction and then you come back this way. Oops, no, I think I got that one not going in the right direction. It goes in the opposite direction. I can't draw it with this one. Then when you reach it, we go back this way. Okay, so if I use this, it goes back this way. Are you okay? All right, great. So once you establish this quickly, if you know the edges of the photographs, you can establish the side lap, which is somewhere in there. Is that okay? All right. Then we talk about the W. So look at W very well. W is supposed to be the lateral advance. So this is the W. Why is this the lateral advance? Okay. Why is this the lateral advance? It's not what I told you in class. What I told you in class is this one. This is W. So why do you think this is also this is W? I mean, seriously speaking, anybody who gets this right, you shouldn't fail this course. I want an answer from the class. Why is this one here, this W that is against where I put the love sign? Yeah, because I'm in love. I don't know who I'm in love with anyway. We'll talk about that later. But why is this being called W when in fact we know the W is the distance between the flight lines? This one, you have to know your geometry to answer it. Why is this one being called W, lateral advance, whilst we know that this is the definition of W is this one? The plane went this way and came back this way. Juliet, can you figure out?
So let me think, please.
Okay, maybe I'll help you so that we go faster. Is that okay?
Okay.
You see, these two lines, they are parallel to each other, aren't they?
Yes.
Yes.
And they have the same distance, they are the same distance apart. All right. So when you actually look at this line here, okay, which is actually the line of symmetry between that divides the side lap into two. Okay, you can see that this line too does the same thing. It also divides the side lap into two. They offset each other by the same distance by geometry. I think it just follows that if you have four parallel lines, so more or less if I drew a line through here, okay, and I went downwards, this line will move by the same amount on the other side. Okay, so it's kind of symmetry, are you okay? Geometry and symmetry between the lines. That's the only way to explain it. Otherwise, it wouldn't make sense why this is being called W, because that is not, but of course, W is lateral advance. What it means is that if I move from here to here, oops, let me get a better arrow. If I move from here and I'm now flying here, okay, you realize that this line will also move down here by that same amount that I have moved from up here to this point, making this distance W the same as this W here. So originally this wasn't, of course, so that is why W should be called a lateral advance. But the actual definition for W will be the distance between the flight lines. Okay, so yeah, it's just equivalent. The distances are the same. End of story. Okay, great. So we have W being that, and then B, I think B makes sense because B is simply the distance between what exposure stations. Okay, so B is from here to here because the center of the photographs are all along this line. Okay, remember that if you look at the centers, let me do the centers again. You realize that the center of this first photograph is where the green mark is. So if you look at the center of this one, to be somewhere here, then the center of this next photograph is around here. Center of this one is here, center of this one. So there are 6 photographs we are looking at. Center of this is around here, center is around here. Okay, so approximately we put the green markers there. But so we cannot define a certain area B and W okay, so that the area is actually the area is defined by B times W. You're doing programming, so when I times, if I push that asterisk, you understand. So the area of this stereoscopic neat model is B times W. Is that okay? So in this area, you can observe, a stereo model. Okay, even though it could be larger than that, but this is, we can easily use this, for calculations, okay, in the future. Okay, so this is the so-called ground coverage and stereoscopic need model. Okay, great. Move on. So example, let's look at this example. All right, so what are we calculating? Area photo taken from flying height of 6,000 above average ground with camera having 5 inches, which is also 152 millimeters focal length, and then 9-inch, which is 23 centimeters format. End lap will be okay. So let's write down the given parameters. So when you start from the top, we have flying height H, we have focal length, have the format D, we have the end lap 60%, percentage end lap 60. Okay. All right, so I should have actually written this one 6,000 focal length. Excuse me, 152.4 millimeters. Feet. So once you are dealing with feet and millimeters, they don't agree. So straight away, you have to find a way 23 centimeters of doing a conversion, but of course, 60% overlap, percentage and lap, and a side lap, so just side lap, 30%. So what is a ground covered by a single photograph and by the stereoscopic neat model? Okay. So the question is asking for what is J and then what is W times B. So straight, you need to know what you are being asked to calculate and compute. Is that okay? All right. So J is actually, okay, what is the area ground covered by single photograph? So a single photograph will have J squared or J times J. Is that okay? Okay, so obviously, yes. So this is it. We are being asked to compute this area and that. All right. And then W and then B. And we've been given so many parameters which we can use. Are you okay? So straight away with flying height and then focal length, you see, I see scale in there. Are you okay? And then once I use scale against D, then I get my G. Are you okay? Last week we did a calculation like that. Okay. that is the first thing that you look at. So intentional, I'm just gonna move down. Okay, so you see we work out a scale, all right? Then G format, yes, this is what I'm talking about. Are you okay? So here we are working in imperial units. Is that okay? And so our answer will be in imperial. So you need to know how to do this. 12 inches make 1 foot, but in this case, it's even easy. The answer is obvious. So J squared, then there's a conversion factor to get it in acres. Is that okay? Easy. W, remember that B is equal to 0.4 J, and then W is 0.7 J. I hope Julia, do you remember this formula I put on the board last week? B called,
Yes, sir.
yes, based on the percentage, there's a percentage of the ground coverage J, okay, that gives you the lateral and then the linear advance. Okay. All right. So now you have area and this factor. If in an exam you are not given this factor, it shouldn't be a problem. You'll be marked. Okay. If you get the idea correct, you marked. Okay. You don't have to. You can just write this in feet squared. But you don't leave it like that. You can write feet squared. Otherwise, if you are given a conversion factor, then you expect to get an answer in that format. Okay, so there you go. Ground coverage based on scale, flying height, photo scale. Are you okay? You can have W and a B, and like, of course it helps you to know the area that your scopic needs coverage needs model is going to cover. Is that okay? All right, let's move on. See this class day, the way you are quiet. I know one day either you like me or you won't like me, one of them. Anyway, so important consideration, weather conditions. It's very important that you look at the clouds. Are you okay? It should be less than a certain percentage. Okay. Sometimes you need this overcast thing. Are you okay? Overcast conditions be favorable in certain conditions, which means that you have a little bit of cloud. Are you okay? Large scale photos, photographic mapping over built up areas, forests, steep canyons, etc. Clear sunny days may cast troublesome shadows, and so a little bit of overcast is needed. So casting a shadow is called overcast. Are you okay? So when the skies are not too clear, then you have what we call overcast. And so yeah, you don't need completely cloudless skies for your photographs. So you need to look at the weather conditions. It depends on the time of the year. Always remember that. Okay. Cloudless day may be unsuitable. Okay, no cloud at all. But then sometimes you can have what we call atmospheric haze. You can have dust. Depending on whether you're actually do your project in the place where it's an industrial area. Okay. So when it has finished raining, then you can go and take your pictures. If you want to do a photogrammetric something survey for a very busy place, you always do it after the rain. Yeah, after the rain, to just the rain will just wash everything down. Pollution, yeah, we're having some pollution there. Season of the year, look at what we call the sun angle. Is that okay? Sun's altitude, yes, the sun altitude. You should look at some trees, they shed their leaves, have deciduous trees. Are you okay? And so you need to look at that. Oak trees tend to hold their leaves until spring. You need to know all this before you fly. Just don't go and fly. You end up easily gone. All the trees are covering everywhere, and you be wondering what you just did. Okay. So normally photos not taken when snow covered. You see, so snow, no, sometimes you need snow, sometimes you don't need snow. Are you okay? Because the snow tend to cover everything. You don't see what is there. Are you okay? So you can't even interpret your photos. Are you okay? All right. So it's sometimes desirable, sometimes not. It depends on how you look at it and what you do. All right, so the sun's altitude should always be below 30 degrees. So the sun has an altitude. Maybe if you do some field and geodetic survey or something like that, you will know that the sun has an altitude. So in some countries, the sun doesn't go above a certain what angle or altitude. Are you okay? The sun always comes to a certain point, and that's it. Maybe you have to travel the world to appreciate what I'm talking about. Okay. Someone will not contribute, but you put on the mic. That's why I go quiet, because someone is just unmuting the mic, but they won't say anything. Anyway, so shadows sometimes are beneficial if you want to know if there's a pole. Okay, some fence posts, power posts, you can easily identify them by their shadows. Okay, so you need to know that. All right, so one of the final things that every photogrammetry should know is to be able to draw a flight map. The flight map will show where the flight lines are, okay, where they should be, are you okay, how many photos are we taking, and things like that. Okay, so you always have a base map upon which you overlay your flight map. So that's a typical one we are looking at on the board. Are you okay? So yeah, it always overlaying or something, but you always need a base map. So typically, if you look at this one, 6 flights are being taken. The camera being used is a 6-inch Zeiss camera. Then we have the scale, 1 inch to 500 foot. You need to convert this to SI units or like unitless IOK scale. All right. Hold plan for telephone. Go. I mean, you can see this is definitely for a pilot. Can you see that? All right. Go ahead after panels are placed on section corner monument. So you can see we talk about pre-marking here. All right. Flight crew copy. This is not the type of flight that you are going to visit your uncle in the US. Okay, this one is going to bring you some money. Now up here you can see 1, 2, 3, 4, 5. These are the fly lines. Okay, so this is how we fly. We start taking the photographs from here. 1 starts here, ends there, 2 ends there, 3 is longer. Okay, so which means we didn't need these quadrants. Like this is called a flight map. So how you actually prepare a flight map, is what we want to just touch on, and then we close. Okay, because I think you can't wait to hear me say we close, which it's really unfortunate that it should be like that. Okay, so flight planning templates exist. Is that okay? Depending on how you do it, you can do an overlay and all sort of things can be done. Can use software to do everything that we are talking about in this class right now. So typically, okay, and sometimes this comes in exams, or maybe half of this question comes in exam, and you are supposed to calculate and determine total number of photographs required for the project. Is that okay? Now you have to bring on board everything that you've learned in terms of coverage, side lap, linear advance, lateral advance, number of flight lines. Use common sense actually to answer questions like this. So you have a project area which is 10 miles long. Are you okay? East and west, 6.5 miles wide, north-south direction. What does that mean? So you need to even figure out what that statement even means in the first place. Okay. So if I'm to draw something like this, means east is actually longer in the east-west direction. So the project area looks like this and not like this. Are you okay? It looks more like this than this. Are you okay? It looks more like this than this. So that's the first line statement we say. Photography should be at a scale of 1 in 12,000. Okay. So we have thought about it and we have actually come up with that. So it will determine, so of course, flying heights. For example, 60% end laps, 30% side lap, no problem. Okay, then we have the camera focal length. Okay, and 30% blah 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 focal length blah blah blah. Okay, format is also given. Prepare a flight map on the base map whose scale is, so the base map rather has a scale of 24,000, but we really want to what make a what photographs which are actually one in fly in such a way that we have 1 in 12,000. Okay, my internet is not stable. Doesn't mean sometimes you don't hear me, but I think MTN is causing this. Yes, my Vodafone isn't working too. So Amang, yeah, I was being hard on you. I know. Is he gone? Amang is still there. Okay, that's good. So yeah, we need to first understand the question. Once you understand the question, you know how to proceed. Is that okay? All right. So the secret to this, I'm just going to give you an overview because we are not in a classroom per se. You need to now put in the fly lines. Are you okay? All right. You know the length of your project area. Okay. Why should your fly lines go in the east-west direction? That's the first question. Juliet, why should it go in the east-west direction?
Yeah.
And not the north-south direction.
East west direction, not the north south. So
Mhm.
because you are taking the
Take it
you're
easy.
flying high.
Take it easy. Before you
So
get it
I've
wrong.
lost the film is gone.
The idea is this, the answer is gone.
Yeah.
This direction is that is if the lines have been selected to reduce the number of flight lines.
Okay, so we choose the east-west to reduce the number of flight line, because if you are to go in the north-south direction, we will have to actually draw more lines. Because let's not forget that we have a certain fixed scale, and we have what a certain overlap. Okay, so these are predetermined. So if you count now, you realize that you have 1, 2, 3, 4 here. 1, 2, 3, 4, 5, 6, 7, 8. It means the aircraft will have to be turning around and coming back, when we go the north-south direction compared to the east-west direction. This is it. It comes in exams. Questions like that come in exam, and people don't. Someone will write something funny, then I also give them 0, a big one, with akukuti. Among ask the Ghanaians what akukuti is, they will tell you. Okay, so
Okay.
yeah.
I'll access this later.
So we have to first appreciate how we are going to arrange our flight lines, whether they are going to go in north, south, or east, west. I know we've already determined how they are going to go. Is that all right? The next thing is also to establish whether we want to place the first line, where we want to place the first line in there. So once you've done that, the secret to this whole thing, understanding this whole calculation, is to take this length and then divide it by the lateral advance. Are you okay? Because remember that we are moving in this direction. Okay, so lateral advance divided by the length of the project area, adjusted by the first and last flight lines, okay, will now help us to get the number of flight lines that should go in the project area. Okay? So it's like sharing bread. Listen to me. It's like sharing bread. Cut the end of the bread for the dog, and then the rest, cut it into maybe 5 millimeter, 10 millimeter, 10 millimeter chunks. So how many pieces would you be cutting if the bread is so long? You have to subtract the end of the total length of the bread and then cut it. I get that. That's the wisdom of determining the number of flight lines. Okay, and the number of flight lines will now help you using the linear advance. Linear advance is moving forward from left to right. You are able to now determine the number of photographs on it based on the airbase. Are you okay? All right. This is the long and short of it all. Now to plot something which is actually here, okay, on this one, then you have to just do some kind of enlargement or something like the change in scale. Are you okay? This changes by 2 times. Okay, so that's not a problem. All right, so I'm just going to show you. I think you've all seen, if you actually downloaded the material, you know how this was done. All right, so in the first step, you have to draw, oops, draw up and appreciate, are you okay, where you want the lines to be inside it, are you okay, right, where you want to place the first line, and then you then work out the number of lines based on the lateral advance. Okay, great. So east-west fly lines, the dimension J is going to be needed, of course, and it's easy, quick formula. We've done this before. W is 0.7 G because you have 30%, side lap. Okay. Then we place the lines in such a way that we have to cut off this bit, 1,800. Are you okay? From both ends, like I said, like bread, cutting the ends of it, and then the remainder we now divide by the length. Remember that 6,300 is on one side of the shortest side of the project area. Remember from the question, we have 6.5 okay miles. Okay, so there we go. We have that, we subtract it out, and then we work out the total number of flight lines. Then it's what, 4.9, but you have to approximate it. And then, of course, know the relationship between lines and spaces. Are you okay? It's very important to know that when you have 3 lines, how many spaces do you have? When you have 3 lines, how many spaces do you have?
2.
You have 2. You have 1 and then 2. So therefore, number of flight lines equal to number of spaces plus 1. Okay. But the reason we are dealing with spaces, you understand very soon. You understand why, because the spaces are what you're actually taking a picture of. Okay, so guys, basically, this is it. You just carry on through. And then let me clear this one. You adjust your percentage side lapse. Are you okay? And this formula, you can easily appreciate it. I mean, I don't have to even go through it. All right. Linear advance, I think I already talked about it. Number of photos per strip, okay, can be calculated. You add a few photos to be sure, are you okay, to avoid any uncertainty. You add a few photos, you add 1 plus 2 plus 2, and then so that you have enough photos to be taken for calculation purpose. So the economics of it. Excuse me. Total number of. Timo, you switch off your mic because you haven't said anything since we started. Switch off your mic. You keep on playing music and all these things. Spacing of flight lines on map. Okay, so we can also do that. Is that okay? Based on the scale that we've been given. All right. And so the rest just follows. The rest just follows. I think basically that is that. I'll touch on projects specification, project specification. I think in the first last week's meeting, I touched on specification, where we work out the scale which is needed, IAK, the experience of those who will be working on the contractor. You need to look at that. You need to look at the tilt that is acceptable. We talked about the crab, IAK. I remember I talked about this last week. I think basically that is that. Okay. So the project specification is what you are actually working towards. And then you are good to go. But you should be, as an engineer, determined that they should be flying this way. So that the most important thing is appreciating the calculation here. All of you, you have to go through this. I'll you never know, it may come in exam. Yeah, when it comes, I will make it interesting. It will be the same as this. You need to understand it to answer it. Is that okay? All right. And then that is basically it. Are you okay? For photogrammetry 1, you have assignments to submit. Please submit the assignments. Those who haven't submitted assignments, someday don't come and blame me. You see me somewhere and you look at my face, you say this man is wicked. Don't ever say